Welcome. This is your friend Jim. Welcome to All Logs Plastic Hubs. Thanks for stopping by the channel. And I've got a doozy today. I finally got back in the machine shop and doing some work. Before I explain this, I want you to understand that I've been very busy lately, a lot of personal stuff going on. Guys, get everybody around the computer, the TV, or however you watch these videos, because this is going to be a good one. What we're doing today is I've been having parting off issues. Self-inflicted parting off issues. The reason why they're self-inflicted is I went to a different design thinking it would be better. My other design holder that I made a while back, my one piece, never give me any trouble. But it does take some complicated machining to duplicate. That particular holder's on loan to a friend right now because he was having parting issues. So I don't know how I hadn't got a report back from him on that holder. What I wanted to do is start fresh. So here's what I've done. I've got a GT4 blade. It's a little bit wider tool. Reason being it's a heavier blade. And the blades with these long blade-like holders, that helps a lot. Two, I built a simpler system, and I built one similar before. I never had it on video. I let it go 5-6 years ago with another lathe, because I sold all the tooling with it because it was the smaller toolbox. And ever since I've let that holder go, I've regretted it. It was never any trouble. So here's what we're going to do today. We're going to start out with hunks of steel and channel iron, and somewhere in the middle of all this mess is a tool holder. I'm not sure when I'm doing this opening is how long this video is going to be. I'm going to go ahead and make it one video now. I've said something a minute ago when you see the closing about 2, but no, I'm going to make this in 1. So if it's long and boring, hang in there. I've tried to be conscious when I filmed. I'll be conscious when I edit of your time. So appreciate your time. Hey, let's get over here and start slinging this chips and steel around. We got a doozy today for you. Come on, let's get started. Good morning, this is your friend Jim. We're back on the tool holder project. I started on this thing. You probably won't see it. I just made a complete, absolute living mess out of it yesterday. And I just think it's best to start all over and redesign everything from the ground up. So what I'm doing now is I've got a piece of cold rolled plate steel that's come out of the block, and I'm sawing this morning. And that's what we're going to talk about. Sometimes I do things is I make stuff out of what I have. Since I'm making this new tool, I want to put a plate over it to bolt to hold everything up. Well, I don't have a piece of plate. And if you follow the channel a lot of times, you'll know I buy stuff a lot of times out of a scrap bin and such stuff as that. So I'm going to make a cover, and I decided the way I'm going to do this is use a plate to go over the holder, the cutoff tool in between. So really what's going to happen, all this particular plate's going to do is basically machine gets the holder adjusted. It's loose and hot and set through. You can adjust the blade where you want to, and it's kept very firmly. All the actual stress on the blade will be held in the tool bar that we're going to make. I've done this before, and except I had better stuff, and I tried another idea yesterday that you may never see on camera, and it just didn't work, and I goofed up. I look at using a saw as a roughing tool. So what I'm doing is I'm only going to use this piece of the steel here for a base. So we'll clamp it in the mill and flatten it out. I'm trying to do it along my rough sawing. Okay, this is the little sawed off planks. Now we're going to get on the milling machine. What I'm going to do first is I'm going to fly cut all this stuff square. But because I don't want to, I've got this little 3/4 mill in right now. I'm going to set up kind of, and what I'm going to do is rough this out. Kind of try to get this sort of flat. As I say, I use a saw for roughing, so that's what I'm going to do. So let's fire the mill up. Take some lighter cuts, take a cut and see what's going to happen. Well, that's what we're going to do. All I'm going to do with this 3/4 mill is basically level this out on both sides. Just to make it a little easier to fly cut. Because it takes a while to fly cut. That's the plan. First pass. The fly cut you can't take for about 20 miles at a time. This is the main block. I'm going to do it basically the same way. Fly cut. Square it up. It's more efficient. So I don't want to take much off. Okay, now what we're going to come back to here is I'm making a block. I showed some of the fly cutting. So, and the reason I like to use a fly cutter is just it takes a lot out of it. It's a little more, it takes a little longer because you can't take big cuts. But now I've got a good square block to work with. So now I've got everything trued up that I'm going to work with today. This is probably piece A36. It was in my scrap pile. So now I'm going to begin to do the dovetail. I'm not going to, obviously it's a lot of work doing dovetails. I'm just not going to show all of it. You've seen me cut these suckers. So basically what I'm going to do here is lay it out. And a quick way to explain the way I like to do it. Anytime I can do it through my x-axis, I prefer to because I can use power feeds. I always, when I start on a block like this isn't got a specific size. I've kind of made it around a size I think I need. So I'm going to cut the dovetail in first. I'm trying to come up with the idea of starting in basically about the same place as a XL block, and then so when I put the tool in, I'll have all this on the other side to be thinner. I want the block a little thinner to get me away from all my adjustments. That's pretty much going to be fairly close. I think that little bit of extra overhang is not going to hurt me too much. So we're going to try it and see. I think, that much overhang is not going to be too bad. I've been trying to make these things too thin, and I believe I just ain't got enough meat behind it, I guess, so to speak. So we're going to try that. So basically what I'm going to start here with is I've got it set up. I'm going to go ahead and cut the center of the dovetail out and cut the dovetail. Once I do that, then I can flip the tool over to the other side. One of the challenges of dovetails is getting these suckers to fit good. When they slide off and on and lock. You want them to lock good. And when you're milling these things, sometimes when you're milling these things, I don't know, maybe it's part of it is these import blocks that don't release good or whatnot, but they're a challenge. I have never been able to mill one of these, and see right there, you still feel like it's hanging and giving, but you don't see anything. Unless it's just, so You burr, you chamfer, and you grind on them, and you polish on them, and they'll get to fitting better. But you'll notice it's a little tough sometimes. See, right around the top of the dovetail, for some reason, I don't know where it swells out right there or what. They just don't fit good. There he is. So now I don't want to take no more. I think that's the fit I'm going to live with. But that's the trouble. And I'm going to say something that if Mr. Pete happened to be watching this video, is going to jump straight up and down. I have to take this thing out several times to fit it, taking very light thousandths cuts, and it's basically hand fit this. This one's actually bigger than my sample piece by 4 thousandths before I even started milling on it. I don't quite understand it. I don't know where the 60-degree cutters we're using is exactly the same or what. I mean, I use Randy Richards cutter, so I know I've got a good cutter. I just think a lot of it is here in the bottoms, when we don't get these bottoms exact. I think that's the problem. I try to get them as exact as I can, but I think that's it, a lot of it right there. This whole project is when you're designing something without a drawing and out of your head, but you have an idea. There's a couple things you want to do with this. And these blades have always presented these issues. You wanting mass. Mass is your friend, but you don't want to be too much mass. A lot of the commercial deals, you're hanging way out here, and I'm trying to get as close to the compound at the way I like to leave my compound set. Now, yeah, if I had it flat, I wouldn't have to do some of the things, but then again, it's set for threading all the time. So what I've done is I went back to the mill and I took 1/8 of an inch out right here. Now I already have a scribe mark to give me an idea of where my center line, that blade's going to be. And that should be about right here. So I'm going to go back and double check all of that before we start putting the slot in it. Now what I tried to do yesterday was save me several hours of work, and that's just what, to get to this point, I've got about 4 hours worth of machining on this block. I've sawed everything up, and you see me saw everything and true everything up out of some A36. This is probably a piece of A36. It's what you get out of scrap. So now I'm to the point of machining for my blade. So now they'll set all that up. All right, what I've done is stripe the mark on this, obviously, to give me an idea. And I've done some double, triple checking. Most every production tool holder is around 425 to 450 thousandths. The ones that I have. A couple of them I checked. This is going to be somewhere around that 450 range or maybe a little more. I'm going to shoot for around 450, so I'm a little above my mark. I'm going to make the first pass, measure it, and see where I'm at, and then figure out the widths. One other thing, I'll walk you around here. This is where your DRO comes in real handy. This is a reference. It won't have any, just like when I cut dovetails or whatever. What I've basically done is just set me a 0 in my y-axis. And if I got to make any adjustments, I can go from that way, and I'm knowing how much I'm cutting, the direction I'm going in. So it gives me a little bit of leeway. Since I'm not working off a center like I do with a dovetail, this still is going to be effectively working for me. Okay, what we've got now, yeah, you see what I've done. I've got a little bit of clearance here, so we're going to go ahead and pull it out. I'm going to go over here to the lathe and check it. But that's kind of where we're at. See, that way I'm supported. What's going to keep this in place is the plate that goes on the top. I'm going to do a little bit of saw measure. Well, the problem is this is going to be real thin. I'll bring you back. Hey, now, off camera, what I've done was I squared this up. and then I drilled the 4 holes. What I'm doing, and I'm working on right now, is I'm drilling these holes, and then I'm going to, what I've done was transfer punch only 2 of them right now. So what I'm going to do is tap this one quarter 28, and then we'll see how it works and go on to the next one. That way all my plates going to line up the way I want them to. So here we go. Folks, we're going to have the first test right here. I done lined everything up. We're going to see how well this is going to work. Everything's been put on center. I'm going to use feed rate, inserts in there, and tools built. We're going to see what happens together. I mean, I already took a little cut to make sure I was on center and see what's going to happen. So we're going to let it rip. I want to get back to where I was. Then I like the bigger blade. This is giving me more rigidity, and this whole setup idea is to gain rigidity. I've got this blade set out 1.25 inches from the block. Now I'm using power feed, the GTN4 insert and blade. I just bought 2 new ones from Shaw's for this purpose. I don't think I really need the wider insert, but that wider blade, that heavier blade just gives you just that much more rigidity. And that's right here is a piece of cold rolled steel. It's chucked up in my lathe, slowest speed like I like to part. And we're just letting it part and see how it cuts off, see what it looks like. This is the first test of the hole. Centered up, put together, everything. So we're going to see. Looks like it's doing a really good job too. I know it wasn't the inserts as much as when I started having troubles when I switched over to that other holder that I tried to make. A friend of mine has actually got my other GTN3, and I don't know how the heck this worked for him. He had a lot of parting issues too, and there was a lot of discussion. I said, why don't you try this? Because I ain't had before I built that other solid one-piece holder. I never was a fan of that design. We're getting down there to the nitty-gritty. The only bad thing about parting off with this slow speed like that, especially on a solid, you get down to the nitty-gritty and it takes just, you have not very much surface footage. The toughest thing to do is part a solid piece off. You ain't hear no jerking, no popping. And again, I'm letting the machine feed, so this is the hardest case. It's getting there. It's getting her down there. And this is the hardest way to do it. So I'm not doing myself any favors. Just cutting it. It's just, when it gets down this small, it kind of, what you like to say, strings it. There you go. How do you like that, folks? That's just neater than crap. Now that's just neat. I'm tickled to death. All right, let me bring it, and I didn't have a lot. Let me bring it out and show it to you. This was what I was trying to build from all along. I like this design because it's simple. You ain't got to do a lot of crazy machining. Basically, you got 4 bolts. These are 4 quarter 28s, 4 quarter 20s to adjust it. Solid block that I machined today and everything. It's pretty. Done. Well, there is the finished tool after I blacked it. I'm sorry I didn't go through every step with you, but a lot of it's just repetitive machining that's been on this channel. Here's some of the features of what I was doing. This tool is made out of a solid block, so it's got a step in it to clear. So all this contributes to make things very rigid. And rigidity with cutoff is your friend. Quite frankly, I I've always liked the bigger the insert, the less trouble I've had. Just see, and you get a stronger blade with it. So basically what you see here is I started out with another idea, didn't work. Basically what I did is took a solid, you see me do this, found some material I had, took a chunk out of it. One of the things this A36 doesn't blue good. It's good as it's cold rolled, cold blue. So I cold blued it. You seen this plate was a piece of channel iron actually. You seen how I done that. But the rest of the machining, like the dovetail, something I probably cut a lot of them on the channel. I just didn't feel like going through and reboring you with that much extra stuff. So it's got dovetail to fit the B block. It's got the, this is the part I like to do in a cutoff tool, and this is why I messed up with a couple of other designs. You can make fancy holders and stuff, but sometimes simplicity is just a lot better, and this is simplicity. You basically have a slot, you got screws holding it, grub screws holding it with a plate. That just keeps it from moving. And in this way too, all this in here is rigid. That's rigid, this is rigid, so it takes out a lot. Yes, you'll notice I use what I like to do for adjusted screws, this 1/4-20 rod. I've never had any trouble with it. All this is for is to hold it in height. All your height and pressures help with your dovetails and your block. You've seen how well it worked. That's the first test. I got aggravated doing some simple work the other week trying to cut stuff off. I've not been happy with that other one I played with. The other design that I've made before is a lot better, but it's still relying on having some fancy milling up here at the top. This is a lot easier to build and does a lot better. If you want to use the GT3 blades, then I will tell you that I will work just as well. I went with the 4s because I felt like that 4 blade, the heavier that blade is, because this is where all the pressure is right here. Then you just got to have something back here to support it, keep from moving. So especially at the slower speeds that you're trying to cut steel off at, I'd like to cut about 140. My lathe just don't give me 140. I really go from like 200 to 70, so that's always a challenge on steel. So there's the tool, and I'm going to go ahead and just do the closing with this. Guys, this is copyright production. James Dedman, All Those Plastic Hubs. I appreciate you coming by the channel. I appreciate you stopping by and sticking with me through this project. I'm going to try to get this thing together. I don't know how much time it's going to take. It may be one part, it may be 2. If it's 2, you'll see 2 different videos, just depending on how things look. So I'm glad you stopped by. I'll see you on that very next video.